Welcome to today's lesson. Today we will be able to find the distance and midpoint of a line segment. And we will be able to explain the steps we need to take when finding the distance and midpoint of a line segment. So let's take a look at today's Do Now. Let's take a look at today's Do Now. What is the equation of the line that passes through the points 5, 2, and 7, 9, written in gradient intercept form? So try this out, write your equation in the given form, and we will check ourselves after. Alright, so the equation of this line should be y equals 7 over 2x minus 31 over 2. Let's take a look at today's thinking. How do we find the distance and the midpoint of a line segment? So we have the distance. We can find the distance of any 2 points using the distance formula. We will not need to graph any points with this formula. The distance formula can be obtained by creating a triangle and using the Pythagorean theorem to find the length of the hypotenuse. The hypotenuse of the triangle will be the distance between the 2 points. Hence, here's the distance of our right triangle. The distance formula is given to us, in which the first point we are going to label x1, comma y1. The second point will be x2, comma y2. D is the distance or length between the 2 points. The midpoint. Sometimes you will need to find the coordinates of the midpoint without graphing. The midpoint theorem states that the coordinates of the midpoint of a line segment are the averages of the coordinates of its endpoints. So the midpoint formula is written in this form: c sub x, add your x's, divide by 2, c sub y, add your y's, divide by 2, where c sub x is the coordinate of the x value or the x coordinate. C sub y is the y coordinate of the midpoint, and the midpoint can be written as c sub x, comma c sub y. So in order for us to do this, I wrote down the steps. First thing you should do is label the first endpoint, x sub 1, y sub 1. Label the second endpoint, x sub 2, y sub 2. Use the formula. Substitute each value. Find the values of c sub x and c sub y and write your midpoint as an ordered pair. So let's take a look at the first example. Example number 1, finding the distance and the midpoint of a line segment. So consider the points A, 4, -6 and B, 2, 8. Find the distance between A and B. B, let M be the midpoint of the line segment. Now, a new notation: whenever we are talking about a line segment, you're going to see it in terms of this. We have been used to seeing AB with a line on top, but IB uses these brackets to represent line segment. We are going to find the coordinates of M. So let's start with part A, finding the distance between A and B, which means I need my distance formula. I'm going to write my formula down. Now we have our first point A, our second point B, and it does not matter how you label it, as long as the first number is x, the second number is y. So I'm going to substitute this into my formula. I'm going to evaluate. And I get the square root of 200, but I can simplify this further. by multiplying square root of 100 times 2, giving me my distance to be 10 radical 2. You should always simplify those radicals if possible. For part B, we are using the midpoint formula, which says add up your x's, divide by 2 for your c sub x. For your c sub y, add up your y's, divide by 2. I'm going to plug in and evaluate. So here c sub x would be 6 divided by 2, which would give me a value of 3. C sub y would be 2 divided 2, which would give me a value of 1. And I am going to represent the midpoint, which is m, as an ordered pair, 3, 1. Let us look at the next two problems. So for number 2, line segment PQ has endpoints P 4, -7 and Q 2, -1. What is the length of the line segment in simplest radical form? So I know length means that we are looking for the distance, which means that we are going to use the distance formula. So I'm going to do the same thing I did before. I am going to rewrite my formula and do my substitution. You guys try this out. All right, so I got up to the square root of 40. It does tell me to represent my answer in simplest radical form, so I know I can break this up as rad 4 times rad 10, giving me the distance to be 2 radical 10. For question 3, the midpoint of DF is -1, 5, and the coordinates of F are -3, 2. What are the coordinates of D? So in this case, they have been giving us, or they have given us, the midpoint to be -1, 5, which means that is the value of c sub x, c sub y. They gave us one of the endpoints, f, -3, 2, and I am just going to label that x sub 1, y sub 1, and I am looking for the other endpoint. So I am looking for x2, x sub 2, y sub 2. Let me write my formula. So to find the midpoint, we add up the x's, divide by 2. To find the coordinate of the y, we add up the y's and divide by 2. Now in this case, they gave us the midpoint itself. So they gave us the final answer, c sub x and c sub y. I am going to substitute my c sub x and substitute my x sub 1. I do not know what x sub 2 is. I'm going to do the same thing for c sub y. At this point, what I see is I could set up a proportion and cross multiply. So let me cross multiply. And what I'm looking for is solve for x sub 2. Now, if that gets confusing, just name it x without the sub 2, but it doesn't really bother me, so I am just going to deal with it. X sub 2, I would add 3 to both sides, which would give me a value of 1. Let me do the same thing for the other side. I got my x sub 2 and my y sub 2. Let's put those together and write my ordered pair for D, which would be 1, 8. So keep learning, keep growing, and I will see you in our next video.